Hello everyone and welcome to my presentation. My name is Federico, I'm a PhD student of Paulista University in Brazil and today I'm going to present my work. The title is Management of Organic Waste Fraction in a Brazilian Food Wholesale Market, Environmental Impacts through a Life Cycle Assessment Perspective. Worldwide, landfilling is a common way to dispose municipal solid waste. In Brazil, 60% of municipal solid waste are discarded in this way. This generates a lot of environmental impacts like, for example, methane emissions to atmosphere and leachate generation. These impacts are generated by the degradation of the organic fraction, and if we evaluate the main sources of the organic fraction, food supply centers play a key role. Food supply centers are concentrated wholesale markets for products, usually horticultural, where sellers and buyers directly perform market agreements. The food supply center object of this study is called IWACP and is located in São Paulo City, in Brazil. Now, let's have a look on materials and methods used in this work. IWACP is the biggest food supply center of all Latin America. An average of 10,000 tons of horticultural products are traded each day. 150 tons of waste are generated each day. Organic fraction is more or less 8%. In 2018, almost 100% of organic fraction generated were sent to landfill. Now we can see how our system works. The food arrives, is traded inside IWACP and sold. A small percentage of food that is edible but not more sellable is sent to charity institutions by an internal food bank. Food that is not sellable or edible becomes waste and is sent to landfill. This is the system under analysis, highlighted in yellow. It's composed by 5 different steps: internal waste collection and transport, waste transfer, transport to landfill, landfill disposal, and waste degradation. In the first step, food waste is collected by 8 garbage trucks and moved to a special area where there is the second step. The second step is waste transfer. Here the waste is transferred to a bigger truck. The third step is transport to landfill. The fourth step is landfill disposal. And the last one is waste degradation. The leachate generated is treated outside the landfill in a wastewater plant that therefore was included in our system. The goal of this study is to evaluate the environmental impacts of the organic fraction generated by IWACP in 2018 according to the life cycle assessment guidelines using the recipe midpoint methods. About the functional unit is 1 ton of organic fraction, and about the impact categories, we choose the most related to the waste management according to literature. Now we can start to see the results. About global warming potential, the main contribution of greenhouse gases emissions is provided by the methane directly released to atmosphere. That is the 86% of total emissions, followed by diesel consumption in vehicles. This is linked to the process of waste degradation, and to have the confirmation, we can analyze the contribution of each step inside this category in the next slide. As expected, 19% of greenhouse gases emissions are generated during the waste degradation process, confirming the role of methane. About the other impact categories and comparing all inside each category and not among different categories because data are not normalized, we can see that steel has the highest weight in human toxicity and metal depletion potential with values of 73 and 50% respectively. We can also highlight that diesel consumption dominates in fossil depletion with a weight of 75%, while diesel direct emissions are preponderant in particulate matter, photochemical oxidant, and terrestrial acidification potential with values of 93, 76, and 96% respectively. The values found in the last four impact categories suggest an important role of diesel fuel, strictly connected to transportation steps. To confirm this link, we can assess the contribution of each step in the diesel fuel consumption and related emissions. The contribution of each step in fossil depletion, particulate matter formation, photochemical oxidant formation, and terrestrial acidification generated by diesel use and combustion shows that internal collection has the highest value, 50%, probably because it is the step that involves the highest number of vehicles and the related diesel consumption. The categories freshwater eutrophication, terrestrial ecotoxicity, and water depletion show an important role of phosphorus in freshwater eutrophication and a light preponderance of gravel in terrestrial ecotoxicity and water depletion. In the categories where there are direct and indirect impacts, direct impacts are by far more important. Avoided emissions generated by electricity production from landfill methane have a small impact in global warming potential, probably because in Brazil electricity is generated by hydropower plants. In the other impact categories, avoided emissions generated by electricity production have an important effect in fossil depletion, where they neutralize the total impacts. In human toxicity, with a big reduction, and especially in water depletion, where the total impact becomes negative. Discussion. In global warming potential, the greenhouse gases emissions is dominated by methane generation from waste degradation in landfill. This is confirmed by the works of Oliveira and Lincoln on two waste management scenarios in Brazil, considering the landfill option. Another confirmation is provided by the work of Zile Rodriguez about a landfill in Peru. About particulate matter, photochemical oxidant, terrestrial acidification, and fossil depletion potential, we have seen that transport plays a key role, as again confirmed by Lincoln. Electricity generation has a small effect due to Brazilian electricity generated by hydropower plants. Conclusions and suggestions. To reduce the pollution, if we don't want to change the system, a good idea could be the substitution of the old vehicle with new models, as suggested by Larsen. In this way, we can reduce the pollution generated by transport until 60%. If we totally rethink the system, we can recommend to increase the efficiency of the food bank that should reuse 100% of edible food, donating it to charity institutions. About the not edible food, this type of waste could become the raw material for a biorefinery facility. Thanks for your attention, and I want to thank FAPESP and Paulista University for the opportunity to develop this project. Bye!